Let's think of an arbitrary curve here fx, and at any point x0 on the x-axis where the curve is at curve, the point is fx0, and let's take another point little away from x0, x0 plus del x. So this difference is del x, and this point, let's call this one x0 plus del x. Now if we take this straight line, the gradient is here fx0 plus del x minus fx0 divided by x plus del x, x0 plus del x minus del x0. So that becomes here del x and fx0 plus del x minus fx0. Now this gradient doesn't represent anything significant here, this straight line. But if we take this point very close to the original x0, that means if we can make, basically if we make the second point very close to the original, or we can say that del x is very small, it is infinitesimally small, so small that del x tends to 0. So basically it's just a little bit away. Then this straight line actually becomes the tangent, and this expression becomes the gradient of the tangent. So if we say del x tends to 0, del x here, and this is x0 plus del x minus fx0, this expression becomes then the gradient of the tangent, because this straight line then becomes a gradient of the curve at that point, basically at point x0, and of course this expression becomes the gradient of the curve, gradient of the tangent. Now this is also the definition of the derivative of the curve at that point. So this is the derivative of the curve. So fx over dx, definition derivative of fx over dx at point x is equal to x0 is defined by this one, limit del x tends to 0, this is del x and this is x plus del x. Now I have replaced the x0 with x because I'm talking about generally any point x, basically it can be x0, it can be something somewhere else, anywhere in the curve, basically we can do that. And this is the definition of derivative of a curve. This is also represented by a prime, and often this del x is represented by h. So limit h tends to 0, h x plus h minus fx, and this is the derivative finding from the original definition, and often it's called derivative using first principle. So whenever in a problem we see that a curve is given and an expression is given and we are asked to find the derivative using first principle, we know we have to use this formula, which I intend to do in the next video.